Hi, this is Mrs. Wiederholt, and welcome to my lesson video on writing polynomial equations from zeros. Now let's get started. Before we can learn how to write these equations, we have to understand what it means for a zero to have a multiplicity. Well, it basically means how many times a solution, or zero, appears in the original equation. The best way to do this is to look at an example. So we have f of x equals x plus 5 times x plus 2 squared times x minus 1 cubed times x minus 7 to the fourth power. First, we need to find the zeros. Now we do this by looking at the binomials. The first binomial is x plus 5. Now you take that x plus 5, set it equal to 0, and solve for x. Therefore, our first root is negative 5. Now, there is a shortcut. Basically, whenever you set the binomial equal to 0, the factor will end up having, the root will end up having the opposite sign of the factor. So I can look at the second binomial, x plus 2, and know that my root is going to be negative 2. And then I look at the third binomial, and my root is going to be positive 1. I look at the fourth binomial and my root will be positive 7. Now I'm ready to find the multiplicity of each of these zeros. You do this by looking at the exponents after each binomial. Now if you look at x plus 5, you don't see an exponent. So we know that means the exponent is invisible 1. So our first zero has a multiplicity of 1. I look at x plus 2, and the exponent is 2. So that means our second zero has a multiplicity of 2. And I continue this. My third zero has a multiplicity of 3, and my fourth has a multiplicity of 4. Okay, so what does this look like on a graph? Well, we're going to use this graph right here, which represents this equation. I also want to make a note that the y value, this y-intercept here, is 500K or 500,000, and this one is 1,000K or 1 million. When your curve goes through the x-axis, the factor x minus x1 will have an odd exponent. So let's look at our example here. Our first binomial is x plus 5, which means the zero is negative 5. And we know it has a multiplicity of 1, which is an odd exponent. Now here it is represented on the graph right here. And do you see how it's crossing through the x-axis? Okay, through the x-axis where x equals negative 5. So this tells you that your multiplicity is an odd number, and in this case, 1. Another note I would like to make is that if you notice, it goes straight through the x-axis. There is no curving, and so that means that your exponent will be 1. Now, when your curve bounces off the x-axis, as it does right here, and as it does here, that means your factor of x minus x1 will have an even exponent. So if we go to our example and look at the second binomial, x plus 2 squared, and that means our zero is negative 2. That's right here. And as you can see, it's bouncing off of it. It's not going through it. This represents an even exponent. Now let's look at the other two roots or zeros on this graph. The next one, we have x minus 1, so that means our zero is positive 1. Now here again, you see that it goes through the x-axis, which means that our exponent would be an odd one. Now, by looking at a graph only, it can be hard to determine whether the exponent for this or the multiplicity is going to be a 3, a 5, or something greater. The one thing you can determine by looking at the graph is the wider that this flatter portion is, the larger your multiplicity or the larger your exponent would be. And the reason for this is because in this portion right here, especially as it gets wider, yes, it's It is going up and down like this, but it is so microscopic that we can't see it to the naked eye. You would have to zoom in so much that you would not be able to see the rest of the graph. Therefore, because of how we're zoomed out, it appears to be flat, but it's not technically flat. Now let's look at our last factor. We have x minus 7 to the 4th power, which means our root, or our 0, is positive 7. And because it bounces off the x-axis, we know it's even. And in this case, it is 4. Now, whenever you're given a graph like this, you will be given the multiplicities to help you write the equations. So now let's start writing some equations. Let's look at our first graph here, our first example. The first thing I notice is that I have 3 x-intercepts. So that represents 3 zeros. The first one is going to be, I believe, negative 2. The second 0 is positive 1. And the third 0 is positive 3. Now, when analyzing this curve, I notice that my first x-intercept, my first 0, it goes through the x-axis. So that means the multiplicity is an odd number. And I come back, yes, my second root, or 0, also goes through the x-axis, and so does the third one. So that tells me all 3 of these zeros have odd multiplicities. Now, they appear to be going straight through, which would tell me they have multiplicities of 1. But I do need a little more information. And if you look right here, it tells me that this graph has a degree of 3. Well, if it has a degree of 3, that means here is 1 degree, a second degree, and a third degree. So yes, each of these have a multiplicity of 1. So in order to write this equation, I need to take my zeros and turn them into factors. And all I have to do is change the sign. So I have f of x equals x plus 2. Remember, invisible exponent of 1. Times x minus 1 times x minus 3. So there you go. You've just written a polynomial equation by looking at the zeros. Now let's try another one. Now in this graph, as I analyze it, I do see that it either crosses through or touches the x-axis in 3 places. So that tells me I have 3 zeros. Now it doesn't necessarily tell me the multiplicity yet, but I know I have 3 of them. And I know that this one, because it goes through the x-axis, will be an odd multiplicity. This one, because it bounces off, will have an even multiplicity. And this one goes through and it will have an odd multiplicity. So first, let's record our zeros. Now for this first one right here, that is where x equals negative 6. And then our next one is x equals positive 1. And then our third one is x equals positive 5. Now let's look at the extra information that's given us. The graph on the left has a degree of 6. Okay, at first you might think that's not helpful, but really it is. This right here represents a degree of 1. The line goes straight through. There's no curving as there is here. Well, that means there are 5 degrees left. Well, we know this one has to be even, and this one has to be odd. Well, 3, if this were a degree of 3 or had a multiplicity of 3, and if this one has a multiplicity of 2, 3 plus 2 is 5. So that means this 0 has a multiplicity of 3. This one that bounces off has a multiplicity of 2. And this one that goes straight through has a multiplicity of 1. So we're actually ready to write our equation. So it will be f of x equals x plus 6 to the 3rd power times x minus 1 to the 2nd power times x minus 5 to the invisible 1st power. Now I have a question for you. What form are the above equations? Are they in standard form or factored form? If you said factored form, you're correct. Next, we are going to learn how to write polynomial equations from zeros, but when we don't have a graph to look at. And we're also going to learn how to go ahead and change them or convert them from factored form to standard form. So for a quick review, when you have the zeros, you can create binomials or factors in this form right here. The n to n1, n2, and n3, they just represent different exponents that you might have. Okay, example 1. The zeros of a function are 5, 3, and -2. Therefore, the function in factored form would be what? Now, if you notice, it doesn't say anything about multiplicities. If it says nothing at all, that means you can assume the multiplicities are 1. So let's write the equation. So we will have f of x equals x minus 5 times x minus 3 times x plus 2. So how was that? Well, let's try another example. This time, in example 2, the zeros of a function are -4, -1, and +3. Now, it does give us some more information. It says that the zero of 3 has a multiplicity of 2. So let's go ahead and write that equation in factored form. We will have x plus 4, or I should have said f of x equals x plus 4 times x minus 1, times x plus 1, and times x minus 3 to the second power. Now, in both of the above examples, we have written the equations in factored form. So now how can we write these or convert these to standard form? Well, if you're reading ahead, you can see that we are going to use distribution. I will first multiply these two binomials together, and I will end up with a trinomial. Now, when you have a binomial squared, you will also end up with a trinomial. And then I will multiply those two trinomials together. So let's get started and see if we can do that. So first, you're going to multiply x times x, and you'll get x squared. And then you have x times 1, and then you have 4 times x, and those will be the like terms that you combine to get 5x. And then you will multiply 4 times 1, and that gives you 4. Now, to multiply my binomial that's squared, well, that's going to be x times x, which is x squared. And it's really -3 times x plus -3 times x, which is -6x. And then it's -3 times -3, which is 9. So now we have our two trinomials, and we are ready to use distribution to continue this conversion. Now, we will distribute each term in the first trinomial to each term in the second trinomial. So that means we're going to say x squared times x squared is x to the 4th. X squared times -6x is -6x to the 3rd. X squared times 9 is 9x squared. Now we move to the middle term. 5x times x squared is 5x to the 3rd. 5x times -6x is -30x squared. 5x times +9 is +45x. Now we move to the third term. 4 times x squared is 4x squared. 4 times -6x is -24x, and 4 times 9 is 36. Now all we have to do is combine our like terms, and we will have our polynomial equation in standard form. When combining like terms, I just start at the beginning. I look to see if there's any other x to the 4th powers, and there isn't. So I bring that down. That's going to be my first term. I now move to my x to the 3rd power. I have -6x to the 3rd and +5x to the 3rd. So combine those and you have negative x to the third. Next, I move to my squared terms. I have 9x squared minus 30x squared plus 4x squared. And that will be negative 17x squared. Now I'm ready to move to my first degree terms, which is 45x and minus 24x. And that gives me a positive 21x. And now there is only one constant, so I just bring it down. So there you have it. There we have converted our equation from factored form to standard form. Well, I hope this video has been helpful in your learning how to write polynomial functions from zeros, and I look forward to working with you again. Bye-bye.